Even today, about 65% of electricity in India is generated from thermal power plants, and 85% of the country is dependent on thermal power plants, i.e. coal, for generating electricity. To generate 500 megawatts of electricity, 250 tons of coal is burnt every hour at the thermal power plant. You can imagine, and after this, the efficiency of the thermal power plant is only 30 to 35%, i.e. if you burn 100 kilograms of coal, only 30 to 35 kilograms of coal will be converted into electricity. The rest will be losses, and coal is made from trees and plants. So if you are wasting electricity, then you are indirectly harming the environment. So in this video, let us understand in detail how electricity is generated at the thermal power plant. The first requirement for generating electricity is water. So if you have noticed, any power plant is installed near the source of water. Whether it is a thermal or nuclear power plant or a hydro power plant, first of all, coal is brought from the coal mine to the power plant with the help of a train, and this coal is emptied inside the coal yard. Coal yard is the place where coal is kept in the power plant for coal management, and this coal yard consumes around 50% of the space of the power plant. In India, in the year 2018-19, 622.22 million tons of coal was used to generate electricity, and this coal is either extracted by digging the ground or is produced by cutting trees. For example, Coal India is the biggest coal mining company of India. So when this coal is taken out from the mines and brought to the power plant, it contains a lot of impurities. So first of all, the best quality coal is separated from it. Then this clean coal is transported to the furnace with the help of a conveyor belt. But before reaching the furnace, it has to go through another process which is called the process of pulverization. In simple terms, the coal is ground very finely with the help of a ball mill. And the coal is ground so that where the coal burns in the furnace, it can burn completely properly. The entire energy can be extracted from every single atom of the coal. So when this ground coal burns in this fire furnace, this boiler is placed on top of this furnace, which you can see, so the water keeps circulating inside these pipes of this boiler, and this water starts getting heated by the fire of this furnace. Inside this boiler, the water is rotated inside these pipes so that fire can be lit from all sides of these pipes, and the water can be heated quickly to form steam. The water used inside the boiler is mineral-free water, because when there are minerals in the water, it will take more time for the water to heat up and turn into steam. Now the question arises, where does the water come from in the boiler? So the water in the boiler comes from the economizer, and the economizer is like a small tank which you can see, and this economizer is set touching the fire furnace so that the water gets a little heated by this furnace before going into the boiler. And where does the water come from in this economizer? We will talk about it later. You will understand it better there. Now in this thermal power plant, two biggest problems arise regarding this fire furnace. First, when so many millions of tons of coal are burnt, then the management of the ash formed from it. Now you can imagine that to generate 500 megawatt electricity, 250 tons of coal is burnt every hour. And the other problem is that when coal burns in crushed form, there is a fear of it flying into the environment in the form of smoke through the chimney, because if even 1 ton of coal from so many millions of tons of coal flies away, then within a few days dark clouds will cover the city. So this hot ash is sent to the cement factory for management, where cement is made, and there are many cement plants which have their own power plant to generate electricity. Secondly, when coal burns, the outer particles of coal settle down, but the lighter particles start flying with the flue gases. So before releasing these flue gases into the environment, they have to pass through an electrostatic precipitator, which is called a specially in short. And this electrostatic precipitator is installed in the chimney of the power plant. So this ESP separates the burnt coal particles and releases the hot air into the environment, and the same flying ash is called fly ash. And friends, this electrostatic precipitator is the device that reduces air pollution. It stops all the smoke and gas particles in the air and releases the hot air into the environment. So by using this device and installing it on the chimneys of factories, pollution can be reduced to a great extent. Let us move a little further. When water is heated very much in the boiler, it starts turning into steam, and this boiler steam has a temperature of 550 degrees to 1000 degrees Celsius. So when this heated steam is collected from the boiler, this heated steam is released on the turbine with high pressure, and the turbine is connected to the generator through a shaft. So when the turbine rotates, the generator also starts rotating. Now these turbines are of many types, Francis Kaplan impulsive. Some of these are used in large ships and submarines, and some are used in airplanes. But the turbines that are mainly used in thermal power plants are impulse turbines. So when this high heated steam falls on the turbine, first of all the pressure of this steam is high and the temperature is also high. So this steam first falls on the high pressure turbine. High pressure turbines are small in size, but they require high pressure to rotate. You can see them here. When this steam passes through the high pressure turbine, the temperature and pressure of this steam decreases a bit. A low pressure turbine is attached in front of this high pressure turbine. These are big in size but can rotate at low pressure also. And this steam exerts pressure equal to 250 kg on each blade of the turbine. So you can imagine how high the temperature and pressure of this steam is. So when this set of two turbines rotates, the generator attached to them also starts rotating. Now when this steam passes through this turbine, there is a condenser attached ahead, and through this condenser, the steam is sent to the cooling tower for cooling, because releasing such high temperature steam into the environment is very risky. Now this condenser has a very amazing job. In a way, it is a very amazing mind of engineers. How they see. When hot steam comes from the turbine to the condenser sends this steam to the cooling tower for cooling. And when this steam cools down and comes back from the cooling tower in the form of water in another pipe near the condenser, then both these pipes are set very close to each other for economic benefit. How? The pipe in which hot steam is going, near the cooling tower, that steam will become a little colder than the pipe in which cold water is coming back, and this cold water, which is coming from the cooling tower near the condenser, will become a little hotter than the pipe with hot steam. So, when this cold water passes through the condenser, it will become hotter than the heated steam coming from the turbine. Because we have to send this water back to the boiler, so it is better that it is as hot as possible, so that the boiler does not take much time to heat the water and make steam. And after the condenser, this water goes to the economizer, which I just told you about, which remains in close touch with the furnace, and from the economizer it is sent back to the boiler to become steam. Now this cooling tower has a wonderful mechanism in which steam is cooled. I will explain its mechanism to you with a very great example. Often you must have seen that in summers the water in the water tank kept on the roof becomes very hot. That water is not even fit for bathing. Now I will tell you a simple way to cool that water, and that too absolutely free. So whenever you go to take a bath, before that take a tub or bucket of water and turn on a fountain in it. This is the fountain used in the bathroom for bathing. When the water comes from the fountain to the tub in the form of droplets, then this water will cool down to a great extent after coming in contact with air. And if you turn on the fan on the drops of this fountain, then this water will become very cold. And this same mechanism is used in cooling towers and in rainwater. You will see that rainwater is very cold. So cold that sometimes it turns into ice and falls down, which we call hail. When the steam is dropped from top to bottom in the cooling tower through a fountain, it cools down on the way in contact with the air and also turns into water, and you can see the cooling tower from below, which is open. Natural air enters it from below and cools the steam and goes out from the top, and along with this air, some steam also spreads into the environment. But there is no harm in it because it is just water. There is water at the bottom of the cooling tower, and this water is drawn by a pump when the power plant is set up near a river or pond. And this water is used to cool the steam, and later this water goes further to the boiler to be heated. Now this generator which rotates generates up to 11,000 volts, i.e. 11 kilovolts from the turbine. This generator works on Faraday's law of magnetism, and I have made a separate video on this in detail. You must watch it by clicking on this I button. Your knowledge will increase a lot. Right now electricity has just been generated. It has to travel a long way to reach our homes. The entire process of this power plant is automatic. A lot of people are engaged to maintain these big turbines, generators and coal, who keep checking the performance of this generator boiler every second. Because the temperature of the boiler is so high that if the boiler explodes, the whole city can be destroyed and even the bones of the people will not be found. And these generators are so big and expensive in size that every single thing about them is monitored. At what speed are they rotating? How much voltage are they generating? How much current are they generating? What is the frequency? What are the losses? What is their temperature? Every single thing is monitored because these generators keep running continuously at full load at a speed of 3000 RPM for 1 year without stopping, and that is why a lot of money is spent on their security. Now when 11,000 volts are collected from the terminal of the generator, this voltage is stepped up to 400 kilovolts with the help of these big transformers. Because when electricity reaches our homes from the power plant, there are many losses on the way. Due to this, it is transferred at high voltage so that there are minimum losses. When this 400 kilovolts is brought to the big GSS of the big city with the help of these big towers, then this 400 kilovolts is stepped down back to 11 kilovolts. Now this transmission line also has to be taken care of a lot. Its load flow is also checked every time, because the effect of 4 lakh volts on them is very tremendous. So when this 400 kilovolts is stepped down to 11 kilovolts by these big transformers, then it is transferred to our homes with the help of this 11 kilovolts line. And if you have seen, before using this 11 kilovolts in homes, a small transformer is installed at the corner of our street or near the houses, which steps down this 11 kilovolts to 400 volts. And this 400 volt has 3 phases and 1 neutral wire. So, with 1 phase and 1 neutral wire, 220 volt electricity reaches our homes, which we use. And sitting in the luxurious comforts of the house, we say, "Yar, why does the light go off?" Electricity is cut off when either there is a fault or the load increases. Otherwise, electricity is available in the power plant 24 hours a day and any time in 365 days of the year. Friends, I have uploaded a lot of studies on this live ADA channel.